With crowd science, we are researching where people move, how they gather, what is their psychology, when do they speed up, when do they slow down, what is it that delays the process, and when does it play in our hands and when does it not. And we basically can take apart any event into free movement, into service, into restrictions, and check, is it all in a balance? What we try to achieve is a balance. Something where we never run out of people, but we also never run into a risk. So basically, we bring the Olympic Games into the city, into an environment that isn't made for it, and it will look similar to what you see here with volleyball under the Eiffel Tower, with fencing and riding in front of Versailles, and potentially even a 100-meter dash on a boat, on the Seine. And if you don't have all the environment that you would have in a stadium, which is toilets, which is security, which is seating, all of those things, if you have to do those in a city rather than in a stadium, it comes with a lot of unknowns, with a lot of crowd issues. And we always ask our students at the very beginning just to also be a bit humble about things. Why did so many people die on the Titanic? And the answers are often ranging from cold water, other ships didn't come to help, or mistake by the captain, or it was all Kate's fault. And those are all correct. But basically, we all know if we slim it down to one answer, it would be there weren't enough lifeboats on the Titanic as there were people that needed to be rescued. So the mathematical equation would be number of people on board minus people that fit in lifeboats. That's the number that you can expect to die in those waters. Obviously, I'm going to the numbers first. More than 190 countries, millions of spectators, six different cities on different continents, and thousands of people, like hundreds of thousands of people running and participating. And they're all wearing a timing device. Wherever they go in the city, even the days before the event, they are always tracked wherever they move. I mean, this makes a this makes a crowd scientist really happy that I can track hundreds of thousands of people while they're moving through the city, and I can use it for my research. I think it makes a crowd scientist just as happy as it makes the NSA that we're all buying cell phones. So we're tracking people mile by mile, but it's not just that. We tracked them before when they use the ferry to go to Staten Island. We tracked them even the day before when they arrive at the expo where they pick up their bib number. We tracked them post finish when they walk through different stages of a festival that is at the end, where they get their clothes back that they handed in before. They're spending some time. They're drinking whatever they want to drink afterwards and hang out with families. So we can collect all this data because the runners, they need to be timed, and for that they wear either a small chip on their shoe, which is basically just a magnet, nothing that requires any battery, or this part of the bib number that they're wearing anyway, that they're picking up from us anyway. So it's basically a magnet strip within the bib number. And all of this we get, and all of this we use to optimize the experience as well as the safety for those races. So how can we measure what the impact actually is? And we said, well, the biggest challenge would be to measure this, to like calculate the finish, sorry. We measure the start, we decide to start in a certain way, and we then can calculate what the impact is for the finish 26.2 miles away. That would be, for us, if we can figure that out, we can figure out everything along the way because that's the longest distance where people do what they do, but we know how they would arrive at the finish based on our start procedure. So basically, we knew we were onto something. We can predict, after knowing one point and knowing the logic behind it, we can predict the next point down the road. May that be running or may that be a service. And that means we can change it. It's in our hands, as it was before. But to be super honest, I don't know if marathon people are on this call, but you might agree that, like, let's say 10 years makes it less embarrassing. But 10 years ago, when we started a race, it was based just on experience, but we didn't know 100%. We just said, let's start in 3 waves. Sounds safer than 2. But that was that. And now we can do it down to 99.9% accuracy. So that was me talking about running. But if we apply this to stadia, and we're doing this constantly here in Manchester, we do like our football. Same as Munich. I just put them on because they're playing each other today. Let's see how that goes. And if we then use a stadium either for a new purpose, which could be in the case of the Allianz Arena that we see here, could be the upcoming European Championships in Germany. They're using the Allianz Arena differently than it's normally designed for club football, or in the case of Manchester City, where they're using the stadium for a concert, something that it's not designed for. They cannot use their normal entrances. They cannot use their normal facilities. Again, we have our balance that is basically out of balance, but we do have our experience, and we do have the rest that we need to fill with an educated guess based on science.